Hey folks. So last episode we went through and we set up the basics for an NPC. In this case, it's a very basic setup where we have our NPC character class and our AI controller that we've defined. Now, as we had mentioned, they use behavior trees and blackboards to decide their logic, store the information to use with that logic, and execute actions. So we need to set up a behavior tree and a blackboard. So I'm going to hop into our content browser here. It's over. I'm in the content section of our project. We have blueprints, our main folder here. We're going to right click new folder. I'm going to go AI. I hate that because it's not going to rename now. Yeah. So it's one issue I found with the editor is you can't fix your capitalizations. You have to change the name and then rechange the name. But anyway, so go into AI. We're going to create a folder behavior trees, and I'm going to make that with the right spelling. And we're going to go into here, right click, artificial intelligence and behavior tree, BT random Rome. I'm going to save that, and then we're going to new folder, and I'm going to do blackboards. And this is just a subfolder. And again, folder organization is going to be down to how you want to do it. You don't have to follow my folder organization. It may not make sense to you. This is how it makes sense to me, though. So in there, we're going to right click. Go into our blackboards folder, artificial intelligence and blackboard. So this is going to be BB random Rome. And we're going to save that. Now, within the blackboard, for what we're doing, we're just going to set up a very basic AI to start with. AI logic can get really complex or really simple depending on what you're wanting. What I want to set up, at least with this first basic one, is going to be something like a deer or another wild animal that's going to wander around. So within here, random Rome, we are just going to need one key. So in the left, we're going to click new key, and we want a vector because that's the location that our AI is going to move to. And move to location. Set that to a very clear name. Now we're going to go back to our behavior tree. We're going to open that up, and you can see it's actually already selected that. Now I don't know how they have that coded. I don't know if it's just based on the first one that it can find, or if it's based on the naming convention. I may have to look into that. But if you find this behavior tree isn't the one you want, you just select it and blackboard, and you select the one you want. In this case, I think it might just because it's the only one. Now, to explain a little bit about behavior trees, and don't worry, we're going to get into some code in this episode, but behavior trees all start with this root. Now, the root is where everything comes in. You'll notice you're only allowed one child from a root. And the reason being is this is literally the doorway into the behavior tree. That's all this root node is. It doesn't have advanced logic or anything like that. You can see here, there's nothing set up. So off the root, you can have a selector, a sequence, or a simple parallel. A selector, the way this works is it's going to, I'm just going to grab some tasks here. They're all going to be weights for the purpose of this description. The way a selector works is it is going to execute the tasks in order, and the first one that does not fail is going to be the behavior that's run. So it's going to go from here, it's going to select this one, and you can see it's got little numbers on them, 0, 1, 2, 3. It's the order of operations that the behavior tree runs through. It goes top to bottom, left to right. So the way the selector will work is it's going to go, okay, does this node fail? Okay, it failed. Let's check this node. Did this one fail? No, it didn't. Okay, we're going to execute this logic. Or if this one fails, then it's going to go, okay, did this work? Okay, this worked, we're going to execute this logic. And that's how a selector works. It picks the first one that doesn't fail. Then you have your sequence node, which is actually the one we're going to be using in this example. where it follows an order of operations. It's going to do task 1, then it's going to do task 2, and then it's going to do task 3. And then finally, I'm not 100% sure on the simple parallel. I believe it does this, and then it does a sort of side logic on this off to one side. And I can't remember the order that they take priority, because this is where my understanding is a simple parallel would be used for something like, oh, you've seen something, I want to run away. So that is something we'll be looking into later in the series. But for the time being, we're going to just set up a basic one to make sure we can getting our AI working. Because there is some slight differences I want to do with regards to the nav mesh when we come down to that. So we are going to drag this down. We're going to set a sequence. And what we want this AI to do to start with is basically find a place nearby, move to it, and then hang around for a few seconds. So, well, we don't have a find point. However, we do have a move to, so we're going to put that here. We do have a wait. Now, the wait, it's a variable. You can say wait for dedicated 5 seconds, and you can add a random deviation. So that's going to be a plus or minus. And I'm just going to add a 2 second on there. Move to, we want to use the Blackboard key move to location, because that's obviously the vector that we need to pass in. I'm going to save this. Now, we need a task to find the point to move to. So you could click new task, and this is going to create a blueprint task. Obviously, this is C++ series, and myself, I prefer to write C++ over blueprints wherever possible, just simply because code makes more sense to me than blueprints. I don't like the spaghetti mess that blueprints have. So we're not going to do that. So as I said, I saved this just to make sure this is saved, because we want to add in this find location node. So what we're going to do there, we're going to go to our C++. We're going to go into a public folder, right click, new class. So in here, we have some basic ones, but obviously there is no task in here. It's not something they expect you to add by default. So you need to go to all classes, and we're going to search task. Now you can see there is quite a few things in here that come up. And your first instinct is probably going to go, oh, BT task node, that's what we need. The problem being is that's actually one step too far back. We need the Blackboard based one, because we're using information from a Blackboard. So BT task Blackboard base. BT task blueprint base, but that is the class that is used for the blueprint tasks that you create. We want this one here, BT task Blackboard base. Next. Now in here, we're just going to name that. So I'm going to call this TF BT task. I'm going to actually call BTT random point in radius. And we're going to create that class. Now I had run the editor from Visual Studio, as this is all being done in one recording session. So we have this reload, and we've made sure everything is saved. So I'm just going to hit reload, and do you want to stop debugging? Yes. All right, so now we're back in the editor. We can start adding a few things in here. So the first thing we're going to want to add is obviously a constructor. So we're going to just copy the class name, and this needs to be, actually, first thing I'm going to do is set up my sections. So the constructor is going to be a public, and this takes in a F object initializer, and that is a reference to the object initializer. And the reason for this is we have, go to definition, trying to figure out where it is. It's back in task node, I believe. There is a reason for that, and I didn't actually note that down so it could cover it, which is somewhat annoying on my part, because I do like to explain why. However, we do have, right here is one of the other functions we're going to need to override. This one here, the node result execute task. So I'm actually going to copy that here, because we need that. And this is an override. And then finally, I want to add in a variable that we can edit within the task itself. So we're going to do uProperty here, just so it's exposed to the editor. Edit anywhere. Blueprint read write. Meta equals allow private access equals true. Float search rate, not floor, float search radius. And I'm going to set that to 2500. So with that, let's just quickly create these definitions here. So this here, the execute task, is the primary one that we're looking at. This is going to be where the logic is defined. So in here, we need to go through and make sure I'm trying to think. Brain's not working. 1 second here. All right, so I took a quick look over my notes just to make sure I had everything correct here. So the execute task, this is a function that is used to determine whether or not it succeeded or failed. And so that's things like with the sequence node, or sorry, not the sequence node, the selector. This is where you would define that process. So this is also where we're actually going to be doing all of our logic. The execute task is basically, okay, do your task and then tell me whether you've succeeded or failed. So this is where we're going to be putting the majority of the logic in here. So what we're going to want to do here, though, is we need to reference, or call back, I should say, to our controller to start with. So we're going to go if, what did we call our AI controller? Grab it here. It's going to be, oh, we're missing the include for that. Equals, cast that to, no, to our controller. But what we're casting here is the, apparently I have a noisy truck going past, the owning component, and we need to get AI. We're missing a reference for that as well, aren't we? On component, get AI owner. Oh, no, it's not a pointer. Sorry, that's half my issue here. Get AI owner. Yeah, it was. It's just because I was thinking it was a pointer. I'm missing a brace, that's why. So what we're doing here is, if we can get back to our AI controller, which is our AI base in this case, we then need to find out where that is. So f vector curlock for current location equals con dot, no, we need to also go back to it as a pawn. pawn? Yeah, pawn will give us get location. So the next thing we want is if a pawn pointer NPC equals cast no, we don't need that. That's con.getPawn. Sorry, I've got notes on this because, as I've mentioned in the last couple episodes, I'm trying to reduce the length of these, just because video performance has been better on the 30-minute episodes versus the 45-hour-long ones. So I've got notes to try and cover everything, and I'm getting used to that. So, okay, now that we've got that, it's an f vector curlock equals npc get actor location. Yeah, so that is where it currently is. Now, this is where we're going to go back and reference the build this one here, the navigation system. We need to find a point within the navigable radius. So we need to include that here. Include navigation system. Because that is going to give us access to things like your nav mesh and finding points within that and leveraging all the existing logic. Now, if you're doing some advanced like AI system that's not using the built-in nav mesh, first of all, kudos to you. I looked into doing that and I realized that was more work than I wanted to do. But also, this process isn't going to work. So the next thing, though, we do need to reference that nav system. So if navigation system, what is it? Is it navigation system? It's a U navigation system. That's why U navigation system. V1. So if U navigation V1 pointer navsys for short form there equals U navigation system V1 get current, and then it's, well, you think get world. So, because that obviously uses the current world context. So now that we have that, we need to also look at doing some additional work there to set a new location. So we want f vector new lock. And now we're not assigning anything here because the navigation system actually has a find a random point within navigable radius. It's just not a task. So what we're going to do now is if navsys get random point, and then this is where get random reachable point, get random point in navigable, and just get random point. So get random point is going to give you a random location. Get random point in navigable radius is going to finds a random point in the navigable space restricted to the radius around the origin. Resulting location is not tested for reachability. And then you have pretty much the exact same thing, but it makes sure the AI can reach it. So that's where you're going to see, with some AI, it's going to go off and it's going to like bump into a wall and just keep trying to walk because it doesn't test. Can we actually get a path there? We want the reachable point in radius. So in there, it takes a vector origin. Well, we have that curlock for current location. We have the, that's where I screwed up. It's an fnav location, not an f vector. Fnav location, new lock. So we want to pass in new lock there. And then we have, it's radius and then that. So we want search radius new lock. Now there is some additional ones in here. You've got navigation data, things like that, but they're not required. So we're going to do that. Now this only returns true or false. It returns true if any location was found, otherwise false. So what we're doing here is we're basically creating a nested set of pass-fail checks. And from those, we're going to be going through and assigning that. So, well, now that we've got this here where we've done that, so now what we need to do is owner component get blackboard, get blackboard component, and then we're going to be set. Do I not have blackboard? Oh, I didn't add the include for the blackboard component. So include blackboard oh, where is it included? Bear with me 1 second. I'm going to find that include. All right, was really, I don't know why I was thinking that. It's in the behavior tree. Blackboard component. So anyway, so it's owner comp dot, because it's not a pointer, it's a reference, get blackboard component. And then now that we have that in there, we should be able to set value as vector. Set value as vector. And then this is where you can define a name, but we have get selected blackboard key. And this is where, like within that move to, we could assign within the details panel on the right. That's what this is. It's get the selected blackboard key. It's using the one that's defined within the UI. So we don't have to provide a dedicated name. So if we have, and in that way we can use different blackboards with this function, and they don't all have to have the same name. Useful to use that for consistency, but you don't have to do it because of that. And then all we're going to do here is new lock location. Now this is where, as I was mentioning, this is basically, it's a series of pass-fail checks. So, okay, did we, I'll clean this up, I don't need that white space line. Did we correctly cast to our AI controller base? No? Okay, so we failed. We're going to be fixing that in a second. Did we correctly cast to the pawn? No, we failed, so that's going to drop through here. Get rid of that white space. Actually, what we can do to potentially offer some refactoring, I'm going to put that in there. Just move that down one. So did we correctly cast as a pawn to get its location? Yes, we did. Did we get our navigation system? Yes, we did. Okay, so now that we've got those 2 bits of information, well, we've got technically 3. But this was just so we could get that NPC. And actually, I'm going to think about some possible refactoring here. We could probably get rid of this top if and just do that down here. But either way, so now that we've done that, we now say, okay, we've got our nav system. So we're going to get a current location for our NPC. We're going to set up this nav location variable, and we're going to see, did we get that information? Did we find a point? Yes, we did. Okay, so we're going to set our Blackboard task. Then it's finish latent task. And there's this owner comp behavior tree component. Well, we already have that, so we can pass that in. Owner comp. And this enum, which is a EBT node result. There's a couple. There's aborted, failed, in progress, succeeded. Well, in this case, we succeeded. And that's just to tell the, I believe that's for the multi-threading, because AIs run on some threads, separate threads, to say that it finished. But we also need to return that EBT node result succeed. So we're going to copy that, and we're going to return. Because in here, we've done everything we need. Garbage collection will clear this up. We don't need to worry about that. So what we're going to do though is I'm going to copy this, and then we've got to do pretty much the same thing here on our fail result. Failed, and I'm just going to copy that for ease. And I'm going to put that in here. So right now, this is the very basics of setting up the find random point. There's one more thing we can do though, and that's actually provide a user-friendly name in the editor. So node name, in the constructor, again, getting ahead of myself, I'm trying to rush, so I'm going to slow things down a little bit. There is a local parameter for nodes called the node name, and this is how it's presented in the editor. So node name equals random point in reachable radius. With that, we've set up this entire blueprint, behavior tree task for how we need it to behave right now. So I'm going to do a build. I'm going to pause the video while this runs, and I'll be back once this build is finished. Okay, so there was a build error, and this is because I messed up the input parameter on the constructor. However, the build error actually tells you what it is here, so we're going to select that line, scroll over a little bit. So it's either without an input parameter, or it's a constant reference, and I missed that constant. So I'll try that. We're going to run another build, and this should actually happen pretty quick because everything else is built now. So I say that, and now it's going to take a while because it actually succeeded. So I'll pause the video, and we'll be back once this build is finished. All right, so that build finished. And just for clarity, I did add the const within the source file as well. I just did that prior to because I realized I needed to show adding that in. So with that, we have finished off pretty much everything here in getting this random task. So what we're going to do, we're going to launch into the editor, and we're going to set up that blueprint behavior tree before we finish things out in this episode. So things are loading up pretty quick in the editor. As I sit here in silence, doing what I don't want to do. Okay, that loaded just as I was about to find a filler. So we're going to go and open up that behavior tree we created earlier on. Do that quickly off to the side here, just for, no, I don't want blueprints, I want AI. All right, drag that over so we can take a look at that. There we go. So now we've got that here. Let's drag off our node, and you can see random point in radius. Really big task name there. And that is based off of not this, which I thought that's what it was, but it's this here. I believe. Is a random point in reachable. Am I blind and my memory sucks? Yeah, random point in reachable radius. Sorry, I am being a complete fool here. It is using this node name. Now, obviously this is a rather large node name, but it is what it is. So now that we've done that, we can select this node, and you can see we have our search radius and our blackboard key. So we're going to set that to move to location. And that blackboard key is what this is going to return, that get selected blackboard key. So with that, we have set up the basics of our behavior tree. This will do exactly what we want it to do. It's going to find a point that's reachable. It's going to move to that location, and it's going to wait for a random variable from 3 to 7 seconds at that location. So I'm actually going to change that to 1 to 5 seconds. I'm going to change that wait just a little bit. So we're going to save that. But with that, folks, I'm going to end this episode here. Next episode, we are going to set up, at least to start with, a very basic AI. We're just going to use the Manny skeletal mesh and the current animation blueprint that we have for Manny, and then make sure we've got the nav mesh working the way we want it. So, as always, those folks, thanks for watching. If there's any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. And I will see you in the next episode.